In this video, I'll be going over how to convert between grams and moles. And so our first problem is, how many grams are in 0.7 mole of H2O2? So for all of these problems, you really want to know where you start and where you're going to finish. Where you start is just what you were given in the problem. In this case, we were given the moles. And where we finish is what we were asked to find. So we know when we have it, we've finished the problem. And that was, how many grams? Alright, so now that we have our start and our finish, we can create our roadmap for doing this problem, which is to follow our arrow that takes us from one box to another, which in this case is going to be going from right to left, and we're going to multiply by the molar mass. That's how we're going to get our mass. Alright, so before we can multiply our moles by the molar mass, we have to have our molar mass. And so for all of these problems that are converting between mass and moles, step one is always going to be find the molar mass. And you find that the exact same way as you find molecular weight, it just has different units. So, alright, our formula for molecular weight and molar mass is to take our atomic mass and multiply it by the number of that element we have in our molecule. So getting this from the periodic table, the atomic mass of hydrogen is 1.008. You can see from our subscript of 2, we have 2 hydrogens in this molecule. And now filling in oxygen, getting the atomic mass in the periodic table, and the subscript of 2. Now all we have to do is to multiply and add this together. Alright, so adding this together, I get 33.996, and so for both of these, I'm not really caring about sig figs at all right now because I'm not at the end of the problem. That's when I have to care about sig figs. So for right now, all I'm doing is I'm looking at my number up here, 0.7 moles. I can see that has 3 sig figs, and so I want to make sure that the atomic masses I pull from the periodic table have over 3 sig figs. That way I know I'm not losing accuracy by the numbers I pull from the periodic table. So as long as you have more than you were given in the problem, you're fine. And then again, another note for molecular weight and molar mass, it's very unlikely you're going to have the exact same answer as the answer key you see or other people that do it in your class. Periodic tables differ slightly in their atomic weights. People are going to choose to pull different number of sig figs out when they're filling in for molecular weight. Don't worry about that. As long as you have a relatively close number, that's going to be completely fine. You're going to get an answer that's acceptable. And so for molecular weight, our unit is AMU. It stands for atomic mass unit, and that's very small. That's how much one proton or one neutron weighs. And for molar mass, we have the exact same number, and our unit is grams per mole. So grams divided by mole. Alright, now that step 1 is done, we're ready for step 2, which is just to go ahead and do our conversion, convert to grams. And we already know from earlier, that's going to be by multiplying by the molar mass. So setting up our number that we were given, 0.700 moles, we want to make sure when we're doing these conversions to draw every number as a fraction, including units. So 0.7 a mole goes on top, 1 goes on the bottom. Now we're ready to multiply by our molar mass. So pulling this up, we can see that our number is going to go on the top, grams is also going to go on top, and mole is going to go in the denominator. So great. Now we can see that our units cancel out, and we're going to end up in grams, which is the whole point of this problem. And so don't get used to having this little conversion here. This is really just there as training wheels so you guys can see what steps you have to do. By the time you're on exams, you're going to have to either have memorized this or know how to cancel out units so that you can figure out if it's multiplication or division. And multiplying out, we get 23.7972. Now it's our time for sig figs and for units. So for our sig figs, all we have is this original number of 0.7 mole. So this has 1, 2, 3 sig figs. This leading 0 is not a sig fig. Because we had 3 sig figs, we made sure that when we were finding the molar mass, we used over 3 sig figs, so that didn't limit us in any way. And now when we have our answer, we're ready to account for 3 sig figs. So with rounding, we have 1, 2, 3, and our final answer is 23.8, and our units, grams. Alright, and so for all of these problems, I think it's really important to get in the habit of doing double checks. And so remember that the molar mass is just equal to how many grams 1 mole of that substance weighs. So our molar mass for H2O2 was 33.996. that means that if we had 1 mole of H2O2, we would have had about 34 grams of it. And so we didn't have 1 mole of it. We had less. We only had 0.7. So now looking at our mass, it makes sense that this is less than 34 grams per mole because we didn't even have 1 mole. So if we had had about 2 moles, we would have expected to have about 68 grams. If we had had 1 mole, we would have expected to have about 34 grams. So always kind of keep these mental double checks in your head, because if you get a wrong answer, you're going to be able to identify it and say, wait a second, that doesn't make sense. I must have had some kind of math error. Our next problem is to convert 25 grams of KMnO4 to moles. And so again, let's start by identifying our start and our finish. We were given 25 grams. This is our start. We were asked to find the number of moles. That'll be our finish. When we have moles, we're done with the problem. And so now we can see for this problem, we'll have to follow the top arrow going from left to right, and we'll have to divide by our molar mass. So once again, step 1 is just to find the molar mass. So filling this all in from the periodic table with what the atomic mass is and how many we have in our molecule. So all I did for sig figs was to make sure that I didn't limit us, and since I have 3 sig figs, 1, 2, 3, from my given number, I want to make sure that I calculate a molar mass that has over 3 sig figs. As long as I do that, I'm not losing accuracy through my molar mass. So this accomplishes this because I have 4 sig figs here. And my units for molar mass are always going to be grams per mole. Now I'm ready for step 2, which is just to go ahead and convert. And so in this problem, I'm going to have to divide by my molar mass. So my math looks like this. And so I can either divide, or to see the units a little bit more clearly, I can also multiply by the reciprocal. So just setting that up so you guys can see it, if I multiply 25 grams by the reciprocal of the molar mass, it's going to look like this. So I just flipped everything in 158.0 grams per mole and put it into this fraction. And so now I can see, all right, my units are going to cancel out. Grams is going to get canceled. I'm going to end up in moles. And now I can go ahead and divide 25 by 158. And I have 3 sig figs, 3 from up here, and 3 right here. So this is my final answer. And again, let's do a little bit of a double check. So my molar mass of KMnO4 is 158 grams per mole. So if I had 1 mole of it, it would weigh 158 grams. And so looking at how many grams I actually did start with, I started with only 25 grams. So if I only have 25 grams and it takes 158 to get to 1 mole, I should have way less than 1 mole. So that makes sense. My answer is actually just 0.158. I have way less than 1 mole because I'm not even close to having 158 grams. So I can't emphasize enough, if you start getting used to these double checks, it's really going to save you from any math errors you start to make, and it's going to be really helpful for your overall understanding of moles and mass. All right, hope this video was helpful, and as always, happy studying. Hey, I hope you liked that video. Please feel free to subscribe, click around and watch my other tutorials, and as always, happy studying.